It's really good to be here. Thank you very much for the introduction. So, what are we seeing? Could we switch to my first slide? There we go. All right, so Uber Elevate. It's an absolute pleasure for me to be here and to talk to this crowd today about Uber Elevate. I actually grew up with the dream of flying. As a teenager, that's all I could think about was just flying, flying, flying. I did get my private pilot's license before I could legally drive, and yeah, so this is where it all started. I did, unfortunately, go and pursue commerce after that, and my flying took a backseat. So it's great to see how the world works and how I've come full circle that I can live out my childhood dream now and talk to you about flying cars. It's not really flying cars, but talk about flying in my job. So that makes it even more exciting for me to be here. So just to talk a little bit about myself, and with Uber, I started my career with Uber here in Cape Town as an operations manager and started doing anything from driver training to setting the growth strategy for the city. I now lead what we call partner channels. And in short, partner channels is expansion in existing markets, expansion in new geographies and with new products. As an example, in the last 3 months, we launched 2 new products, a motorbike taxi product in Uganda and a tuk-tuk product in Dar es Salaam. So it's just the different types of products that we need to start integrating, and I think the piece that I'm going to talk to now is just so much more exciting than what we've got already. So I'm here today to talk to leaders in the aviation industry, specifically in Africa, about Uber's next ambitious endeavor. And this is to introduce an entirely new form of transportation to the market. We would like to call it, and I suppose it's urban aviation, but we like to call it aerial ride sharing. Now, the motivation behind the Uber business model, the rides business, the cars that you see on the road, is not fundamentally different to the motivation for Uber Elevate. Now, this is a picture that is not uncommon to many people sitting in this room. Our motivation starts with the unsurprising observation that transport in and around cities has some serious challenges. And we've come to accept extreme congestion in our cities. In Africa specifically, our big cities, Lagos, Johannesburg, Nairobi, are cities that really suffer from congestion. They're large cities with underdeveloped transport infrastructure that make it almost impossible for the population to commute really easily. So this is where we see the bigger problem, and that's the inequity around in terms of access to resources, access to jobs, access to services in the urban core, because it's prohibitively expensive to live in the core of a city. If you take Cape Town, for example, it's almost impossible to buy property in the middle of Cape Town because it's just so incredibly expensive. And this technology we're hoping is going to contribute to that and extend cities. So in 2045, the UN estimates that 6 billion people are going to be living in our cities. So it just means that this problem is not going to get any smaller, it's just going to get bigger, which is how we addressed it from a city development perspective by building skyscrapers. That addresses the problem of residential and commercial density, but by moving local transportation to the skies, will alleviate transport density on the ground and open up immense mobility bandwidth across our cities. And I think that made us, as a company, start pursuing Uber Air or Uber Elevate. I think it's all about a paradigm shift that's being created by the confluence of battery energy density getting high enough to actually power battery-powered flight, and the autonomy technology that allows advanced fly-by-wire technology and systems to control these aircraft. And when you combine all of that with Uber's ride-sharing model and the network management that we have, and the optimization that comes with it, it unlocks pretty much all the barriers to this problem. Now, we can do this, as Rahul spoken, with existing technology. This is not a new thing. This is not a huge leap of faith that we're making. This is existing technology that we're going to use to integrate into this transportation model. And I think that's how we set out to catalyze the market in partnership with the industry. And it's great to be speaking in a presentation where we've got Embraer with us and we've got players in the industry sitting around a table talking about this future of mobility. I'm going to get a little bit more technical, but I think it's important. So we built a mode choice model, and we call it the flux optimizer, to measure how much transportation demand we can actually capture at specific cost points. Now, what you see on the screen is an example of the thousands of surveys that we conducted when we were researching the trade-off that people make between cost and time of travel, depending on the different modes of transport that you're using. So if you look at Uber, if you look at using your personal vehicle, it could take you an hour to travel 25 miles. UberX, slightly longer if you add on the ETA before. The Uber Pool product, which is an exciting product that we have globally, not yet in Africa, but we're actually sharing the ride. That takes slightly longer, but I think when you compare that to the Uber Air concept, where you can travel the same distance with multi-modes over a lot shorter time, it really does make the case for Uber Air. So what we did is we used this flux optimizer tool of us to model everything around the demand for Uber Air and the network. And we used that by integrating our own data and third-party data over an example city. And you'll see there, you won't see it so clearly, but this is Los Angeles. And we wanted to see how we can capture 100% of the potential demand within a city like Los Angeles, which is coincidentally one of our launch cities. Now, this maps an average 24-hour cycle of it's about 46 million unique trips that happen in a day, and we map that into our model to see how we can actually capture that demand. So by jump to the next slide. So by doing that, we looked at the model, and this model suggests and clusters the V-tollable demand. So making sure that we can actually captivate all that demand and clusters it around nodes. And when I talk about a node is one or a group of skyports where these aircraft would land, and how we cluster them, and the most efficient way to cluster them is very important. It's hard to sequence the positioning and to sequence the build of each one of them if we don't have clear data on what the potential demand is. So this is why we rely so heavily on this flux optimizer model, which allows us to then essentially select where our transport nodes are going to be. Now this is LA again, and this is 40 nodes that we identified within LA that in theory could support 100% of the potential V-tollable demand. So out of these 40 nodes that you see on the screen, 80% of them require between 400 and 800 landings per hour. So that's significant traffic that has to move through these nodes. And 20% of these nodes is more than 1,000 landings per hour. So it's obviously, it sounds undoable, and is it physically possible within a city environment, an urban city environment? As it stands, where there isn't infrastructure like this. So we set out to think about how we can do it. We partnered with architect firms across the world to think about how we can build these skyports in a scalable way that they can manage the traffic flow that we expect to get through this product. So I want to show you an example, and this is just a basic one. This is a basic retrofit skyport that we'd be able to retrofit on a standard parking garage. This specific one can probably handle between 100 and 120 landings per hour. So this is small scale in relation to what we need. But when we talk about the bigger scale, this is it. So let's go to the next slide. Okay, now this is where we see the future, and this is one of the examples of these larger skyports. Now, as I said, we partnered with prominent architectural firms to get their input. And they did all this work for free for us just because they're so excited to be involved with this. And they designed these skyports so that they can handle the 1,000 landings an hour. This specific one by Kogel is designed over a freeway. So the idea there is it has to be close to ground transportation to easily integrate, but at the same time, being over a freeway, it's probably better placed from a noise perspective. So this was just one of the designs, and I'll show you another one a little bit later. I'm sure many of you are thinking, how do we handle 1,000 landings per hour? because that means you have thousands of little airplanes flying around the city. Now, this is obviously a real challenge that we have to get around, and we see it. We see our plan to address it as a dynamic sky lane network that we plan on setting up around cities. So the idea is around a dynamic skylane network, and picture road almost like roads with on-ramps and off-ramps that dynamically change as the demand changes. So in rush hour, there's going to be a lot more lanes on top of each other. There's going to be more off-ramps. The speed's going to be different, potentially faster or slower, depending on how we can do it in the most efficient way. And I think it's super important that as a business we use our tech and we partner with air traffic control to make sure that this is a reality. Now, when we started Uber in San Francisco a few years ago, it was about 8 years ago, we started with a premium product, the Uber Black product, and you get fancy BMWs that come and pick you up, and it was a great concept at the beginning, but we realized the only way that you can really scale a business of this nature and start reaching everybody is to make it affordable, and make it affordable for everyone, everywhere. So the idea behind Uber Elevate is not to create an elite product. If we create a product that only the elite can use to fly in from, what's an example, fly in from Pearl Valley in Cape Town, then we failed. We need to create a product that's affordable. And when we started, we set out on almost a first principled approach on the evolution of costs around this project. So we realized that in the beginning it's going to be more expensive, and as we scale and as we optimize, it's going to become more and more efficient. And the idea is in the near term, when we launch, it's got to be at the same price point as UberX. That's the sedans, the Toyota Corollas that you're seeing running around Cape Town. And then in future, this needs to rival car ownership. And this needs to be the same, if not cheaper, as the variable costs of actually owning and operating your own car. So Raul's spoken about the different vehicles. I wanted to show you some more. The vehicle from Embraer is one of our prized vehicles, but I think it's important as a business to partner with a number of different businesses and see and get input from everywhere. And as you see, these are a number of different examples. And as a business, as Uber, we need to support these aircraft designers in any way we can. So we've got a team of specialists whose goal is to accelerate our partners' programs, whether it's through advice on technology, whether it's providing tools, collaboration, and just making sure that we work together to accelerate getting these vehicles or flying vehicles in the sky. And I suppose one of our designs that you're looking at there, we're busy looking at to test, and the same as with the Embraer models. Now, we've partnered with various vehicle manufacturers. We partnered with the US Army, with NASA, and we've got a lot of people involved in this project. And I suppose as Uber, we need to try and keep everything together. We're not creating this ourselves. We're working with partners in the aviation industry. An important piece that I think people could be asking is how do we, I think this is the type of partners, Embraer in the center there with their vehicle, but it's of the biggest vehicle and airplane designers that we work with. I think an important piece to talk to, and I'm not going to go into the detail, but the way that this thing can be sustainable is if it's 100% electric. A typical aircraft would have 150 watts battery pack. It needs to rapidly charge, and in these skyports that I showed you, these airplanes need to be able to land and within 5 minutes charge 25% of the battery and keep them running in that way. And it's the only way for us to be sustainable. And I think from an energy storage perspective, we've really leaned in to make this technology better than what it is. And leaning into batteries and the systems around batteries and storage is incredibly important. And we need to make this thing realize we need to be leading the charge. Excuse the pun. But we need to be leading the charge if we're going to be able to have test flights flying in 2020 and commercial flights flying in 2023. So as I said, our thinking from day one has to be all electric. Helicopters are not an option. It's just not feasible if we need to get to this scale and optimize the cost as we hope to. The pilots in the room, I'm sure, are interested how we're going to be flying these aircraft. And the idea and the vision is simplified vehicle operations as a path to autonomy. So when we start and when the test flying starts, SVO will be in the initial aircrafts in 2023, and by introducing at that level, they can reduce pilot workload and obviously create and demonstrate the safe product, which we will then use to learn and move towards a fully autonomous vehicle, which is very important if we want to make this scale economically. And it also obviously frees up a seat in the airplane if we don't need to have a pilot flying these craft. So globally, we've seen that several large cities, I suppose, in Africa, in Latin America, and in Asia are going to become megacities by 2030. And we need to make sure that outside of the US, we also make this a reality. Now, our two initial test markets is Dallas and Los Angeles, as I've spoken to, but we've put out, I wouldn't say tender, but we've put out interest response to the world, and it's been phenomenal. The input and the interest that we've had, I suppose it's obvious, but cities that want to be on this pilot and really revolutionize how their cities move around. What I'm going to show you here, it's just the last little bit. This is the typical fly through one of our bigger skyports, and you'll notice there's an autonomous vehicle coming up into the skyport, and then this just integrates the ground transportation into the skyport, and then people can actually move into these skyports and transport. And I think as a business and as Uber, we've been labeled as a disruptive company, and I think if you in this space, it's very risky to ride on your laurels of saying you're a disruptive company. And I think the important piece that we've realized as a business is we have to, as we've disrupted land transportation, we need to disrupt ourselves again. And that's the only way that you can remain relevant in the urban mobility space. So it's really exciting to be part of this. As a business, we're really leaning into this concept, and there's a lot of resources being pushed into it as a priority for Uber globally. So I want to just say thank you very much. It was great talking you through this. Thank you.